Let's practice solving some proportions that involve some quadratics as well. All right, so jumping right into it, the first thing we're going to do is just go ahead and apply our cross products here. So the first cross product I'm going to write is going to be 8 times the quantity of x plus 9. That's going to be equal to the other cross product of x multiplied by the quantity of x plus 2. All right, so after you go ahead and find the cross products, the next thing you're going to want to do is go ahead and distribute. So let's go ahead and distribute this 8 to the x as well as to the 9. Then distribute this x to this x and distribute the x as well as the 2. So if we do that, we're going to be getting 8x plus 72 on the left side. And on the right side, we're going to get x squared plus 2x. You can see because we have an x squared here, we're probably going to need quadratics, right? Now, if we go ahead and move everything to the same side, which is generally what you're going to want to do with quadratics. All right, next I'm going to go ahead and take away everything from the left side so we end up with 0. When we solve quadratics and factor or use the quadratic formula, we want everything to be on the same side. So let's go ahead and find x squared, and then let's take away 8x from both sides. 2x minus 8x is negative 6x. And if we take away 72 from both sides, it's going to be minus 72. All right, so here we have our quadratic equation written in standard form. All right, next what we're going to do here is just go ahead and figure out how to factor this thing. So generally what you do here is you take our leading coefficient of 1 and you go ahead and multiply that by our c value. So we have a, which is 1, and c, which is this negative 72. If you multiply those, we're going to get negative 72. So the goal here is to figure out what two numbers multiply to negative 72 but add to get to negative 6. So this negative 6 comes from the value of b, which is the coefficient from this b term. What we want to do is see if we can find out two numbers that multiply to negative 72, but then add to get to negative 6. So I'm thinking here of using negative 12 and positive 6. I think those will do just fine here. So I'm going to use those as our two, I guess, splitting up values for b here. Okay, so just kind of helping show where each of these pieces are coming from. This is really coming from the product of 1 and negative 72, and then the rest of it is kind of coming from looking to add to get negative 6, but multiply to get that negative 72. So let's go ahead and split this up here. It's going to be this 1x squared or just x squared. We said this was going to be minus 12x plus 6x and then minus 72. So notice here we really just kind of broke up that middle term, this negative 12x plus 6x, and then we're going to just go ahead and factor by grouping here, right? So let's go ahead and just group the first two terms here, then we'll group the second two terms or the last two terms, then factor out by grouping. So this is going to be x is the GCF, and if we go ahead and take that out, it's going to be x minus 12. Then we go ahead and add 6 here and factor that out. It's going to be x minus 12. All right, so notice how we have this x minus 12 and x minus 12 here. So we can take out those as a common factor, as a binomial, and we'll be left with this x plus 6 here. So let's go ahead and just leave this as x minus 12. That's a common factor between these two terms. And then we have this x plus 6 left over. All right, so what values would make this equation true? Well, we're going to be multiplying this binomial by this binomial to equal 0. So if this equals 0, how would that happen? Well, if x is equal to 12, that would be true, right? 12 minus 12 is 0. Then 0 times whatever this is just going to be 0. So that's one of our solutions. Now for our other solution, it's whenever this binomial becomes 0, and that would be negative 6 here, right? So these would be our two solutions because negative 6 plus 6 is 0. 0 times whatever this is would also be 0. So these would be our two solutions for this first one. All right, let's check out number 2. So for number 2, let's jump right into using cross products as well. So let's go ahead and just multiply them. Doesn't matter which one you write first. So it's going to be x multiplied by this x minus 1. That's one cross product. The other one is going to be negative 3 multiplied by the quantity of x minus 8. All right, so once you find your cross products, let's go ahead and just apply the distributive property to both sides of the equation here. If we go ahead and do that, then we're going to have x squared. Yep, it's a quadratic equation. And then minus x is equal to negative 3x plus 24. All right, let's move everything to the same side. I'm going to move everything to the left side here. I'm going to keep that x squared alone. If we add 3x to both sides, we're going to get plus 2x here. And if we take away 24 from both sides, we'll get minus 24. It is equal to 0. So always get these quadratic equations equal to 0 if you're trying to solve them. And so at this point, notice that we have an a value of 1 here. So if you go ahead and multiply a by c, you're going to find out what we're trying to multiply to get here. So a times c is going to be negative 24. So let's go ahead and just kind of set this up here so we can figure out what we're trying to get. So negative 24 is what we're going to try to multiply to get. But what's our b value? B value is positive 2. So we're trying to add to get to positive 2 here, but multiply to get to negative 24. If you think about your factors for a little bit here, I'm thinking of negative 4, and I'm thinking of this positive 6. All right, so negative 4 and positive 6 do multiply negative 24, but they also are going to add to get to positive 2 here. So let's go ahead and split this and make it x squared. It doesn't matter which one you do first, minus 4x or plus 6x, either one is fine. And then minus 24 is equal to 0. So notice how we just kind of split the 2x into these two terms momentarily. And then let's go ahead and just factor by grouping. So let's go ahead and group the first two terms and then group the last two terms. So if we go ahead and factor out the GCF of the first set of parentheses, we'll have x multiplied by the quantity of x minus 4, and then plus 6 multiplied by the quantity of x minus 4 as well. And that hopefully makes sense. It matches. That's really good. Notice we have the x minus 4 here. So factoring that out from both of these terms, we're going to get x minus 4 multiplied by the quantity x plus 6. And this is equal to 0. So what makes this binomial equal to 0? That's if x was equal to positive 4. And then what makes this binomial equal to 0 is if x was equal to negative 6. So these would be our two solutions. All right, let's try a third example here. Let's jump right into cross products again. Notice how there aren't any adding or subtracting parts of this. So this is going to be a little bit easier, I think. One of the cross products is going to be negative x times 5x. So it's going to be negative 5x squared. That's actually being completely the left side here, or right side. And a negative 8 times 10 is going to be negative 80. All right, so don't have to do any distributing here. Let's solve for x. Let's go ahead and divide both sides by negative 5 here. If you go ahead and do that, we're going to get positive 1x squared, or just x squared is equal to 16. And then you can go ahead and just take the square root of both sides here. And so you're going to find that x is going to be equal to plus or minus 4. So you can leave it like that, or you can say x is equal to positive 4 and x is equal to negative 4. So if you see a problem like this, you can just solve by square roots. All right, cool. Let's try another one. At number 4, back to having some addition and subtraction, so we're going to probably have to distribute again, right? So let's go ahead and find these cross products first. So let's take this negative 9, multiply that by the quantity of x minus 2, and that's going to be equal to the product of x and the quantity of x minus 6. Okay, so let's go ahead and just distribute this negative 9 on the left side and distribute the x on the right side. If you go ahead and do that, on the left side, we're going to have negative 9x plus 18. And on the right side, we're going to have x squared minus 6x. All right, so moving everything to the right side, we're going to have 0 on the left side. I'm going to have x squared on the right side. If I add 9x to both sides, we're going to get plus 3x. And if we take away 18 from both sides, it's going to be minus 18. All right, so let's see. We have this trinomial here. What is our product we're looking for here? We have a 1 and we have this negative 18. So multiplying those, we get negative 18. So I'm going to go ahead and just write that up here as negative 18. This is going to be what we're going to try to multiply to get. And then what about our middle term? We have this positive 3, right? So let's go ahead and write down this positive 3. That's going to be what we're going to be trying to add to get here. So let's see, 6 times 3 is 18. But if we go ahead and choose, I guess, specifically a negative 3 and a positive 6, then that adds to get that positive 3 we're looking for here, right? So let's go ahead and split that middle part and say it's 0 is equal to x squared, and then minus 3x plus 6x, and then minus 18. So notice this middle section here does still equate to what we had earlier. Now if we factor by grouping, we can go ahead and group the first two and last two terms here. Taking out our GCF of the first two terms, that's going to be x times the quantity of x minus 3. And then for the second grouping, we can pull out a 6 as a GCF, and we'll have x minus 3. So hopefully you're seeing a pattern with some of the other problems we've been doing here, but we have these common x minus 3 binomials here, so we can say we can factor out the x minus 3s, and we'll be left with x plus 6. All right, so what makes each of these binomials equal 0? Well, x minus 3, well, if x is equal to positive 3, that would be true. And for that second binomial here, if x was equal to -6, it would become 0, and then 0 times the other binomial, whatever that would be, would still be 0. All right, let's check out another one. In number 5, this one actually kind of reminds me of the one we did in number 3 where we didn't have any adding or subtracting, so we don't maybe have to do any distributive property, right? So for one of the cross products, 5x times 2x is going to be 10x to the second power, and for the other cross product here, 5 times 8 is going to be 40. So nice little equation here without any distribution. So let's go ahead and divide both sides by 10. If we go ahead and do that, we're going to get x squared is equal to positive 4. So then we can go ahead and solve by square roots. If you wanted to move everything to the same side and equal 0, you can also factor it and it would be a difference of squares. But here, the square root of 4 would just be plus or minus 2. Just don't forget the plus or minus if you're solving by square roots. So we can say x would be equal to positive 2, or x could equal negative 2. All right, one final example for number 6. We have some addition and subtraction again, so we're gonna need some cross products and some distribution again. So let's see, x multiplied by this x plus 7, that's one cross product. Our other cross product is gonna be 5 multiplied by the quantity of this x plus 3. Okay, so let's go ahead and distribute this on the left side, and let's distribute on the right side as well. If we go ahead and do that, we're gonna end up with x squared plus 7x, and on the right side we're going to have this 5x plus 15. All right, so let's get everything to the left side here. Let's say it's x squared. If you take away 5x from both sides, we're going to get plus 2x, and if you take away 15 from both sides, you get minus 15 is equal to 0. Now, for the factoring portion of this, let's go ahead and see. We have a 1 in front here as a. A multiplied by this negative 15 is going to be negative 15. So that's what we're going to be trying to multiply to get here. So let's aim for that. And then our b value is going to be positive 2. So let's look for a positive 2 in terms of what we're adding to get here. Now for factors of negative 15, I'm thinking of negative 3 and positive 5, just because those would multiply, but also multiply that to get that negative 15, but add to get that positive 2 here. All right, so I'm going to take this x squared, I'm going to split this, I'm going to make it minus 3x plus 5x, which hopefully you agree is the same thing as plus 2x. And then we have this minus 15 is equal to 0. So we kind of just split that, and let's go ahead and factor by grouping. So if you split these 4 terms into 2 groupings here, factor out the GCF, so you have x times a quantity x minus 3. And then for the other grouping, let's factor out a 5 as a GCF, and we have this x minus 3. This is equal to 0. And notice how both of these terms have x minus 3 as a common binomial, so we can factor out x minus 3, and we'll be left with this x plus 5 afterwards, right? Or you could put it in front if you wanted to. Now, for this to be true, for this equation to be true, what would make each of these binomials equal to 0? Well, if you said for the first binomial it would be positive 3, that would make sense. And for the second binomial, if x was negative 5, that would make sense as well. So these would be your 2 solutions. All right, cool. So there you have 6 different practice problems that require some knowledge on how to solve quadratic equations in order to get your solutions for these. So hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.